Bismillahirrahmanirrahim. Assalamu alaikum. We shall use the method of Laplace transform to solve ordinary differential equations. Let us revise that we denote the Laplace transform of y of t by y of s. And we have proved in the previous lecture that Laplace transform of y dash of t is equal to s y of s minus y of 0. Laplace transform of y double dash of t is equal to s square y of s minus sy of 0 minus y dash of 0. So the second formula is obtained by just multiplying this with s and then subtracting y dash of 0. Now this formula can be obtained by multiplying this one with s, and at the end we have to subtract y dash of 0. Similarly, Laplace transform of fourth order derivative is obtained by multiplying this one with s and finally subtracting y triple dash of 0 and so on. So we shall use these formulas to solve ODEs with the help of Laplace transform. Question number 1. We use the method of Laplace transform to solve this problem. So we can write this equation is y dash of t minus 2y of t is equal to e power 2t. And now let us take Laplace transform of both sides. So Laplace transform of y dash of t minus 2 Laplace transform of y of t is equal to Laplace transform of e power 2t. So the first step is to take Laplace transform of each term. And now let us use the formulas of Laplace transform. So we know that Laplace transform of y dash is equal to s y of s minus y of 0 minus 2 Laplace transform of y is y of s, which is equal to Laplace transform of e power 2t. This is equal to s minus 2. And now let us use the initial value, and we know that y of 0 is equal to 0. So we can write s y of s minus 0 minus 2 y of s is equal to 1 over s minus 2. Taking y of s as common, we have s minus 2 into y of s, which is equal to 1 over s minus 2. Now keep y of s on one side and transfer all other term to the other side. So we have 1 over s minus 2 whole square. Now the last step is to take inverse Laplace transform. So L inverse of y of s, that is equal to L inverse of 1 over s minus 2 whole square. Now here we know that Laplace transform, since we know that Laplace transform of t is equal to 1 over s square. And we also know that Laplace transform of e power a t into t can be written as 1 over s minus a whole square. And here a is 2. So therefore we can write from the left hand side we get y of t, which is equal to, from the right hand side we can get that this is equal to t e power 2t, and that is the required solution. Now let us solve question number 1 with another method. We can see that this is a linear equation, and here p of t is minus 2. So finding integrating factor, we know that integrating factor is e power integration of p of t dt, but p of t in this case is minus 2, so we can write that this is equal to minus e power minus 2t. Now let us multiply our equation number 1. This is equation number 1. So multiply 1 with integrating factor, we obtain e power minus 2t into dy over dt minus 2y is equal to 1. E power 2t into e power minus 2t is 1. And now, according to the previous lectures, we know that it is d by dt of the integrating factor into the dependent variable. This one is 1. From this we can write d of e power minus 2t into y is equal to 1 dt. Let us integrate both sides. So we can obtain that this is e power minus 2t into y is equal to t plus constant of integration. And we know that the initial conditions are y of 0 is equal to 0, which means that at t is equal to 0, the value of y is 0. If we put these values in star, we can get that c is equal to 0. Therefore, from star we can obtain e power minus 2t into y is equal to t. And this can be written as y is equal to t into e power 2t. And this is the required solution. And you can see from both methods we get the same solution. Question number 2. As usual, we shall take Laplace transform on both sides of this equation. So let us start its solution. Taking Laplace transform of y double dash of t minus Laplace transform of y of t is equal to Laplace transform of 1. And now let us use the formulas. Laplace transform of y double dash is equal to s square capital Y of s minus s y of 0 minus y dash of 0, and minus Laplace transform of y is y of s. Laplace transform of 1 is 1 over s. And now let us use the initial conditions. According to the initial conditions, y of 0 is 0, y dash of 0 is 0. So we have s square minus y of s is equal to 1 over s, because y of 0 is 0 and y dash of 0 is also equal to 0. This is sorry, let me write it again. This is s square y of s. Now let us take y of s as common. So we have s square minus 1 into y of s. This is equal to 1 over s. And if we further simplify this, we have y of s is equal to 1 over s into s square minus 1. If I further simplify this, I can write y of s is equal to 1 over s into s minus 1 into s plus 1. And now by partial fraction, we can write that this is a over s plus b over s minus 1 plus c over s plus 1. Let us say this is our equation number star. And now just multiply with LCM. We have 1 is equal to a. Actually, what we do here we write 1 over s into s minus 1 into s plus 1 is equal to a over s plus b over s minus 1 plus c over s plus 1. And now let us multiply with LCM. So we have 1 is equal to a into s minus 1 into s plus 1 plus b s into s plus 1 plus c s into s minus 1. And now let us put s minus 1 equal to 0, which gives s is equal to 1. So we have on the left hand side, we have 1. The first term will be 0 and the last term will be 0. So if we put 1, we get 2b. And from this we can get b is equal to 1 over 2. This is the first value. Okay, now let us put s plus 1 equal to 0, which gives s is equal to minus 1. So you can see the first term will be 0 and the second will be 0. And in the third, if we use s minus 1, again we have 1 is equal to 2c, which gives c is equal to 1 over 2. This is another value of the constant. And now let us put the other value, which is s equal to 0. So we can see the last two term will be 0, and from the first term we get minus a, which gives that a is equal to minus 1. Because if I put s is equal to 0 in the first term, I get minus 1 into a. And therefore, now we can write star. Let us write star. So star becomes y of s is equal to a. A is minus 1 over s plus b. B is 1 over 2 over s minus 1 plus c. C is 1 over 2 over s plus 1. And now let us apply the last step, in which we take inverse Laplace transform of each term. So let us take L inverse of 1 over s plus taking 1 over 2 outside, L inverse of 1 over s minus 1, and taking 1 over 2 outside, taking L inverse of 1 over s plus 1. So from this we obtain that this is y of t, and L inverse of 1 over s is 1 plus 1 over 2. This is e power t plus 1 over 2. This is e power minus t. And that is the required solution of this problem. To solve question 3, we shall use formula number 1, 2, and 4. Now let us use the definition of u of t minus a to write this equation in the form y double dash minus y is equal to u of t minus 3. And now as usual we are taking Laplace transform of each term. So Laplace transform of y double dash minus Laplace transform of y. This is equal to Laplace transform of u of t minus 3. And this implies that using formulas of Laplace transform, we can write s square y of s minus sy of 0 minus y dash of 0. And minus y of s is equal to, using formula number 1, we can write this is e power minus 3s divided by s. And now let us use the initial conditions. Y of 0 is equal to 1, y dash of 0 is equal to 0. These conditions are given. So we obtain s square y of s minus s minus 0 minus y of s is equal to e power minus 3s divided by s. Taking y of s as common, we have s square minus 1 y of s, and transferring minus s to right hand side, we have s plus e power minus 3s divided by s. Let us divide both sides by s square minus 1. We have y of s is equal to s divided by s square minus 1 plus e power minus 3s divided by s into s square minus 1. Now it can be written as y of s is equal to s divided by s square minus 1 plus e power minus 3s. Let us write it as into 1 over s, and this is equal to s minus 1 into s plus 1. Let us say this is our equation number 1. Now we use partial fraction here. So we write 1 over s into s minus 1 into s plus 1 equal to a divided by s plus b divided by s minus 1 plus c divided by s plus 1. But in question number 2, we have obtained that the value of a is minus 1 over s, the value of b is 1 over 2 over s minus 1, the value of c is 1 over 2 over s plus 1. Putting these values in 1, we have y of s, which is equal to s over s square minus 1 plus e power minus 3s into minus 1 over s. So let us write this minus e power minus 3s divided by s plus, let us take 1 over 2 here, e power minus 3s divided by s minus 1 plus, taking 1 over 2 here, e power minus 3s divided by s plus 1. And now the last step is to take inverse Laplace transform of each term. So L inverse of y of s is equal to L inverse of s over s square minus 1. minus L inverse of e power minus 3s divided by s plus 1 over 2 Laplace inverse Laplace transform of e power minus 3s divided by s minus 1 plus 1 over 2 inverse Laplace transform of e power minus 3s divided by s plus 1. And now inverse Laplace transform of y of s. This is y of t. So let us write y of t is equal to. Now look at formula number 2. According to formula number 2, inverse Laplace transform of s over s square minus 1 is cos hyperbolic t minus, according to formula number 1, inverse Laplace transform of e power minus 3s over s. This is u of t minus 3 plus 1 over 2. And now we are using formula number 4. So according to formula number 4, inverse Laplace transform of e power minus 3s over s minus 1. This is u of t minus 3 and 2. We know that 1 over s minus 1. This is inverse Laplace transform of e power t. But according to formula number 4, we will write e power t minus 3 because we have to write f of t minus a. A is 3 here. Now plus 1 over 2 u of t minus 3, and again look at here 1 over s plus 1. Inverse Laplace transform of 1 over s plus 1 is e power minus t. So we have to write e power minus of t minus 3. So that is the required solution of this problem. That's all.